Thank you so much for coming today. We have Mr. Vito Leonardo here with us. He's the chairman of the Institutional Review Board, overseeing research approval at ISL. And he does this on the basis of the U.S. Department of Health and Human Services regulations. And he is a graduate from North Carolina State University, where he studied statistics. And he's been with us for a really, really long time, being a PI himself, and also going on and leading the IRB, even helping us form the IRB itself. So it's really amazing to have him here. And Vito, you could take it away.
Hey guys, today I'd like to introduce myself, introduce the IRB, and go over some stuff about statistics that you guys might have questions to. I want to apologize first that my camera is a little dark. I don't know what's wrong with it today, but as long as my audio is good, we should be fine. So the IRB, before you publish a paper or before you do any type of study where you're using human subjects, you generally want approval from an IRB. And what the IRB does is it makes sure that your specific research doesn't provide any harm to the subjects that are involved in the study. So if you're doing biological experiments and you're experimenting on people, obviously an IRB is going to make sure those people are safe, right? If you're testing some type of pharmaceutical drug, right? There are safety protocols in place so that the participants aren't hurt. In our case, where we're doing studies for the social sciences, a lot we're doing is surveys, and the data that we're collecting they're collecting from the participants needs to be protected in a way that doesn't harm them, right? For example, if you're collecting data, and you might when you're collecting data for the particular data set that you're doing, you might collect personal identifying information so that you can know who you're collecting from, right? But this personal identifying information shouldn't be inside the data set that you're using, and you shouldn't really have access to it, right? Because you don't want this type of information to be leaked, right? You don't want phone numbers and emails. You don't want to be collecting someone's social security number. You don't need that for any type of information, right? For any data, right? So that's like some basic stuff. And generally, there are specific questions you want to avoid asking, right? So your questions shouldn't be providing any harm to the participants. If you ask a question, if you're doing a study on suicidal persons and you ask a very touchy question that may cause this person contributing the study to relapse, right? That we wouldn't include this question in the study. So what the IRB does is it looks at your research proposal, looks at your survey questions, it looks at what you're going to do with the data, and let you know if this is suitable and this is okay, right? And generally, the guidelines are you shouldn't be, in our case, because we're not doing actual experiments on subjects, your data you should be collecting should only be data you need for the experiment. You shouldn't be collecting any data that you wouldn't need, right? Example, if you're doing a survey to do some type of study on one thing, you wouldn't ask questions that aren't related to your study because you think the data might be useful in the future for a different study, right? And the reason is every participant in the study has to know exactly what their questions are being used for, why they're being used. All right. So every question you have has to have a specific purpose. You wouldn't just collect data just to collect data because you're not the federal government. All right. Another thing, you want to make sure that the questions you're asking aren't causing any harm, like we discussed. Right. If you're doing a study on alcoholism, and you wouldn't ask a question that might relapse person into alcoholism, right? And this is a little bit subjective, right? And that's what the IRB review board is for, to make sure that the questions you're asking are appropriate. And in our case, because the studies are for the social sciences, this is really this is mostly it. So we really care about the data protection of the individuals and the questions that you're asking, the quality of the questions that you're asking in your surveys. before you do your study, you're going to write a proposal, and this proposal should have basically almost all the details that you're going to do for your research. It's going to include why you're doing your research, what your research is, your proposals, what the survey question you're asking, why these survey questions are necessary, right? And then members of the IRB review board will read it and either approve of it, or they'll send it back to you and say, well, you need to change X, Y, and Z, right? And maybe this certain aspect is wrong. Maybe this question isn't worded correctly. Maybe they might reject it and say that this study is completely unnecessary and is too much invasion of privacy, right? To ensure that you're getting a really good feedback from the IRB. IRB is very, very diverse. So we have people from a multitude of backgrounds. We have, I believe there's on the board, there's an MD, PhD. There's people from different universities, with people from different countries, right? And this gives a lot good perspective on the questions you're asking. So even though some of the feedback you might give is not quantitative, it's more qualitative, you generally have a really good team of people on the IRB. Everyone on the IRB is approved, fairly registered. So it's a really, really good group of people to help guide your research. So any questions on that?
Yeah, so we have a question from Noah, and you could take it away.
Do you want me to ask it?
Yeah. Go ahead.
Okay, yeah, no. So this is just kind of a general question that I found interesting as I was doing the homework from last week. But what role does an IRB play with archival research, where you're just working off past data that's been collected?
Well, generally what IRB does is, in this case, it would be data protection, right? So it would just make sure that the data you're using is not used in a harmful way, and the research has actual purpose, right? So you wouldn't just be taking data and like storing it and creating your own personal database, right? And for that type of research, it would be very easy to pass. You would present your proposal and your study, and if it makes sense why you're pulling this data, then it should be fine. What really we care about is if your research is doing harm to the participants, right? That's the main thing. In our case, that's generally if you're dealing with participants who have issues and you don't want to cause relapses, right? Alcoholism, depression, and stuff like that, or data privacy issues. You don't want to be collecting social security numbers, personal information, and stuff like that. You don't need someone's eye color if you want to do a study on socioeconomic issues, right? It doesn't make any sense.
Great, thank you.
Awesome.
No problem.
Thank you so much. I'll take any questions if you raise your hand from this point, and I'll call on you. All right, we'll take around 2 more questions from here, and Ivan, you can take it away.
So while doing the homework for this week, I noticed that there were concerns about the ability of IRBs to enforce their decisions and enforce their regulations. How would an IRB stop a research group from just not following its command?
Well, in academia and research, we function a lot on honor system, right? So everyone wants to do the right thing. If someone acts unfaithfully, even though they know they shouldn't, generally they would get reprimanded after the fact, right? And they wouldn't be doing research thereafter, right? So you kind of like a one strike you're out kind of thing, because no one's gonna fund your research if you do ethical mistakes, because they don't want their funding associated with you, and no one wants your research part of the research group because it makes them look bad, right? So there's an honor system, and most people that are doing research are very well educated. Most people that are well educated try to do the right thing, and if say the IRB tells you you shouldn't be doing something and you do it anyway, the IRB can't arrest you, right? But what it shows is that someone told you it was wrong, and then you did it anyway, and then there's not really a way you can plead that you didn't know or you weren't guilty or something like that. So that's out of the IRB. What the IRB does is it makes sure that if you do get caught, you get in trouble, that you knew it was wrong before you did it. Does that make
Thank you.
sense? No problem.
Okay, Sanvi, for the last question.
So my main question was that in our reading last week, one of the things that it said was that some IRB guidelines have not really caught up to technological advances involved with research or like new developments involved with research. So do you feel the same way? Do you feel that there's been like changes made in IRB guidelines to adjust for this?
Well, the IRB guidelines are so generally it depends on the proposal, right? So some proposals that are low risk, they might be judged by one member of the IRB. If it's deemed like a high risk research, then the entire IRB would read it and vote on it and so on. So if you have a generally well-educated IRB who is very diverse, at least one person would bring up one of these things. I don't think it's a real issue. I think this issue would come up with maybe an IRB who maybe may not be too up to date with technological advances, but in our case, our IRB is actually pretty young. So the range, the age range for IRB is, I believe it's 22, and then a couple members are up to the 50s, right? So this type of issue shouldn't come up. The guidelines are just guidelines, right? So our judgments of the proposals are more qualitative, right? So if there's one person in the group that is up to date on technological advances, then it shouldn't be an issue. It can be, but I don't think it affects our specific research group.
Thank you.
You're welcome.
Awesome. So Vito, we actually have one more question left if you want to take that.
Sounds good.
Then we'll move on. All right, Kunal, you can take it away.
Thank you. So I wanted to know how voting on proposals takes place. So is it like a simple majority or does it need to have a consensus? How do you decide like which proposals pass?
Okay, so it depends on the risk. So if we look at the proposals and the proposals are all kind of low risk proposals, then one person would read it and judge whether the questions or the research is qualifies, right? If we look at the proposal and it's high risk, then there needs to be a consensus. Everyone should agree. We wouldn't just vote on because if there's a divide and we need to vote, then it's probably pretty risky, right? If that makes sense.
Yeah, and just as a follow-up, so before reviewing each proposal, do you like sort proposals by risk when you get them?
Yeah. So generally with the research that we're doing, it's pretty low risk because we're not doing experiments. The only proposals that we would do that would be high risk are proposals that are in high risk populations, right? So if you're researching like heroin addicts and you're doing surveying heroin addicts in a bit like an area where it might be a little dangerous, right? That's something that the IRB might look at, right? But generally, the ISL is not doing too much high risk research. Most of the high risk research is in biological experiments, right? So we don't really deal with that too much. Generally what you do would be low risk.
Awesome. So I guess that's it with the Q&A. And I just wanted to follow up saying that based on what I remember, I believe all of our proposals were accepted for expedited review, which means only one of the IRB members would be required to approve and defer one of your proposals. So seeing that in the last semester, we didn't have any issues with having a full board review, we had everything pass. After deferrals and resubmissions, everything passed with the expedited review. Yeah, Vito, you can take it away with the rest of it.
Okay, so Ryan wanted me to go over regression and ANOVA with the group. Regression and regression's a little bit complicated, right? Because in order to fully understand regression, you need to really delve into the statistical assumptions of the model, right? But generally, what regression is doing is trying to fit, trying to show a relationship between two or more variables, and it's generally building off the idea of correlation. So I decided a little demo in R, so we go over it. But I think Ryan asked me to just focus more on ANOVA, right? So I'm going to focus a little bit on ANOVA for now. And then if we have time at the end, I'll circle back to regression. So I'm going to start with a small explanation of what ANOVA is, and then try to give some type of demo, okay? So ANOVA stands for analysis of variance. So what ANOVA is trying to do is it's taking a variable, let's say variable y, and it's determining whether the average in different groups differs for y. Okay, so if we had an example, maybe income, right? Does income differ between ethnicities, right? So we have income, which would be the dependent y variable, and ethnicities would be the predictor. So we want to know, does the average income of each ethnicity differ? Well, it's really hard to compare, right? Because you can't just look at the average, right? Because if the average income for someone who's Caucasian is 55,000, and the average income for someone who is Asian is 57,000, are they different? Well, they are. One's 54, one's 57, but are they statistically different, right? What if there's an outlier that's throwing off one of the observations, and they're really almost exactly the same? How do we judge whether they're close enough to be considered the same, right? And this is what analysis of variance does. It's judging the variance of the observations in these groups to let you know, well, is 54 different from 57? Or are they generally the same? And this is very relative to the actual data you're looking at, right? So, for example, if I'm looking at a house, right? I say I want to buy a house, and a house is listed, one house listed for 325. So that the median, the average home price for a neighborhood is say $325,000. The average home price in another neighborhood is $315,000. Well, is this significantly different, right? Is one neighborhood significantly, is the average home in the one neighborhood larger than the other one, right? Well, in terms of home prices, $10,000 is not a big difference, right? So we would say they're probably not too different. But if one neighborhood has average home price of 325,000, another neighborhood has an average home price of 450,000, then we would say there's differences in wealth in these neighborhoods, right? And this is something that's pretty obvious, right? Because we know that $10,000 difference in a house is not that much, considering some houses sell for $1 million, right? But if there's a type of variable where you're not familiar with, it's not completely obvious, such as home prices, right? Then you might need some type of test. And this is what ANOVA is doing. So I'm going to share my screen, and I'm going to show you guys a little demo. Okay, so I have R open here, and I have a data set. So this data set I have is from the UCI machine learning repository. I actually used it in graduate school. So in this data set, we have a bunch of variables, and our goal is to use these variables to predict the quality of the wine, right? And this is very useful if you're in a factory or a wine house, right? Where you're developing wine and you want to know if the wine's going to be good before you pay a wine taster, right? Because it might cost money for your business. So this might be a useful model to build, right? And we could do a regression on this, but today we're gonna focus on ANOVA. So there's a bunch of different variables here, right? We could choose from, and I want to know if wines with low volatile acidity differ in quality than high volatile acidity, right? Okay. So I'm going to create a box plot here. There we go. So in this box plot, we have two different groups. We have wines with low volatile acidity and group with high volatile acidity, right? And I want to know if wines with low acidity or high acidity have better quality wine, right? In this case, if I look at the means, right? Look at this box plot, we see that they're pretty similar, right? And if I check the means, they may be similar, may be different, right? So what ANOVA does is it lets me know, well, is this mean right here different from this mean right here when we look at volatility? When we look from this box plot, we see that about 3/4 of the data of the wine quality for the low group are in this box, and 3/4 for the high group are in this box. So is this mean really different from this mean, right? Because the data has so much overlap, right? How can we tell if this high group is different than this low group, right? Well, if we look at just these means right here, right, we would say, well, of course, they have different means. The low group has the low acidity group has a lower wine quality than the high acidity group. And that may be completely obvious to you, right? But what if we had a different survey, right? What if we had different participants in this group? Maybe this mean wouldn't be here, this mean would be down here. And maybe this mean wouldn't be here, this mean might be up here. Then they might be exactly the same. So what ANOVA does is it checks the variance, right? How spread out the observations are for each group. It lets you know, is it possible that these means are the same, right? Is it possible that if we took a different survey, would these two groups have the same mean? And when we do that, what's checking is, are they two different? So right here, I fit an ANOVA model with the wine quality as a dependent variable, and then this categorical acidity predictor variable as a predictor. And we look at the summary, and we see that these stars indicate that it is significantly different, right? But what is this checking? So what this is doing is it's basically creating basically a confidence interval between the two, and let us know each confidence interval is telling you if what range this mean could possibly be in based on the variance of the data, and if they are significantly different, right? Because now if we have two confidence intervals, right? We have two confidence intervals like this, we look at here, we might say, well, it is possible they're exactly the same. But based on numerical variance, we could tell that from this ANOVA test that they are significantly different. And we could say that wines with high acidity have better quality and better taste than wines with low acidity, right? Because of this ANOVA. Without this ANOVA test, we wouldn't be able to tell just by looking at this plot or looking at the graphs, right? And if we just, this also could have been the other way around, right? We could have observed that this this mean for the high group was significantly higher than the mean for the low group, and said that it's clear that high acidic wines taste better, right? But this might not have been the case. It could have been that they were exactly the same and there's no difference between the two. And we can actually do that. And I can actually show you an example. So let's see. Let's pick a variable that we don't see too much, too many differences in. Okay, so this is a correlation plot. So in this correlation plot, if the bigger the circle is, the more correlated the variables are. So we're focusing on these two, quality and numeric version quality. So we see that volatile acidity is pretty highly correlated with the quality. So it makes sense that wines with higher acidity would have better quality wine, right? But something like here, we look at here is sugar content or chlorides content aren't very correlated. So if I turn this into a categorical variable, then we might see that even though they have different means, the two groups, they aren't significantly different. So let's do chlorides. Okay. Bear with me 1 second. Weird. R is not complying with me right now. Got it. Missing a 0. Okay, so here we have, I split the chlorides predictor into 2 different groups. Now we're going to look at a box plot of the 2. Okay, so we kind of split it down the middle. So here we see a box plot. We have chlorides here. We split into 2 categories. So wines with low chloride content and wines with high chloride content. And we see that wines with low chloride content right here have a lower mean than chlorides with high chloride content, right? So if we look at this data and we just look at the means, we might see that they're different and assume that wines with high chloride content have better wine taste, right? They have better quality. But, however, if we look at these boxes, we see there's significant overlap again. So are they significantly different, right? What if we took a different survey, right? Would these chloride, would wines with higher chlorides still have a higher mean, right? So we could judge that based on the variance, right? Is there overlap between these two groups? So when we fit the ANOVA, right? You see again, right? So even though there is overlap, you do see significant differences between the two. We could extend this ANOVA with multiple predictor variables, right? So we could add more predictor variables here. So we could add this volatile acidity here and then fit it again. And we see that when we look at these groups, we still have different means, right? Once you start moving past one variable, ANOVA and regression start to get a little bit complicated, and we start to lose interpretability unless you have a really good understanding of the variables. So in this case, it should be like this. Right. So, and here we see that this is significant. So we see that wines with high volatile acidity and high chloride content have significantly higher wine quality than wines thereafter. And we see that here, wines with higher volatile acidity also have higher wine quality, and wines with higher chloride content also have higher wine quality. And this data set wasn't meant for ANOVA, right? So there could be different data set, right? Where we got these two groups and two means, and the means look different. They look like they're different, right? But because there's so much variability in the observations, that it is possible, right, that they aren't, right? In that case, that would be similar to the real estate example, where you have two neighborhoods, one neighborhood with a average home price of 315,000, another neighborhood with the average home price of 325,000, right? In that case, we might assume that there's the same wealth between those two neighborhoods, right? Because it's very similar in price. But if we're looking at gas prices, right? So we said one neighborhood has gas of 325 per gallon, another neighborhood has gas of 315 per gallon. That's actually a pretty big difference in terms of gas prices, right? So it really depends on the actual variable self and the variability. And that's what ANOVA does. It's the analysis of the variance and lets us know, are the means different between groups when we take account of the variance? Okay. So I think that I was as best as a superficial explanation of ANOVA that I can give. So if there are any questions, I could answer them, and then I could further explain anything you have, any questions you have.
Yeah, right now, we'll be taking any questions, and you guys can raise your hand. So you Pandita, and then Kunal, you can take it away. And then Sulo.
Okay, so my question is, like, could you just send us some reading or something of that sort so that we can go through the theoretical aspects of ANOVA before we actually go into the R programming context, so that we can analyze the things a bit more better?
Yes. So there's a lot of really good articles. I think I'm gonna compile like 4 or 5. So there's ANOVA. I know there's one ANOVA. One thing I want to send is one on regression and one on the assumptions for regression, right? So one thing I didn't touch here was that the Regression and ANOVA have assumptions, right? So when you fit the model in R or SAS or any program you're using, it's assuming there are certain aspects of the data that are true. And the reason it's assuming them because mathematically, those assumptions need to be there for the models to work and make sense. Okay, so I'm gonna send you a couple of readings that I recommend that should give you a better understanding.
Just a follow-up question. Also,
Mhm.
last week we got a link where there was a certain data camp lectures on R programming. Do we strictly follow those for the course, like for the programming purpose?
R is a unique language because open source. So there are multiple ways to do everything in R, right? So there are programming languages like SAS, which are a product and they're made by a company. In SAS, there's pretty much one way to do everything. In R, there's multiple ways to do something. So there's more than one way to fit in an ANOVA model. There's more than one way to create a new variable. There's more than one way to do a regression. So as long as you're following one of these ways and you're using the proper references, it should be fine.
All right, thank you so much.
You're welcome.
Thank you for the overview, sir. You said that beyond a point, once we reach a lot of variables, ANOVA doesn't really make sense. So what do we use then? Which
For-
model?
Yeah. So, okay, for ANOVA, I recommend not going past 2 predictive variables. Okay, so the issue is that the predictive variables can also be correlated with each other, right? So the more variables that you put into the model, the more complicated it gets. Okay, and then there's a lot of assumptions that you need to follow for the models to work. The reason that these models, ANOVA and regression, these were made hundreds of years ago, right? And they mostly created them working with farm data, right? To optimize a lot of farming and also biological data and research, right? And some physics. When they created these types of models, they did not have a lot of variables to work with, right? And right now we have a significant amount of variables. So if you try to apply these basic type of models to data sets with a lot of variables, sometimes the model, the output, you can't interpret it, and also the output may be wrong because the assumptions aren't followed. And this is why statisticians and computer science scientists have developed so many machine learning models over the past 20, 30 years, right? To deal with the high volume of predictive variables that we have. For ANOVA, I would highly suggest sticking to just 2. Okay. For regression, you could put as many as you want in as long as they're not correlated with each other. Okay. If they're correlated with each other, the predictors, then you might have some issues. Okay. The great thing about regression is there's so many resources online that you could read, and you could always Google your question, find someone else who's already asked the question, right? Because it's the most basic statistical model that we use. If you're using something like support vector machine or maybe a neural network, you might have a lot of issues if you don't fully understand it. But regression is so simple compared to those that even if you have a question, you can Google it and someone would have already asked the question, and you could probably find the answer to it. The most important thing is when you understand the basics of it before you start Googling, right? So you understand the basic, like if you understand like a regression model with 1 or 2 variables, and then you want to know what happens if I put another variable in, or 4 variables, and you could keep reading going forward, right? But if you don't have the basic understanding, you can't self-teach yourself, right? The more advanced model building. If that makes sense.
Yeah, and just to follow up, so ANOVA is one of the models used to imply a correlation, right?
I wouldn't call it correlation. So what we're doing is we're comparing the means between groups. Okay, so what we did here when I showed one group which is wines with high acidity and one group with wines with low acidity, we're comparing the mean taste quality of both groups. Okay, so it's not really correlation. You could think of it as correlation, right? So you might say wines with higher acidity are correlated with wines with better quality, right? If that's what we're going to think about it, because it makes sense. But I wouldn't write it in a paper because it's not correlation. Does that make sense? Right. So there's statistical definitions of words, and then there's conversational definitions of words, right? So when a statistician says that we found significant results, there's a statistical reason why they use that word. There's a definition for it. When they say, when someone else says, just in regular verbiage that something is significant, it doesn't always mean statistically significant, right? And it's the same thing with correlation, right? There's specific meaning of the word correlation in statistics. So in your head, if you want to think about its correlation, that's fine. If you write in a paper, it's an issue.
Got it. Thank you.
Okay, so thank you for giving this lecture to us today. So my question is, are IRB's ethical boundaries valid for other countries than US, other than US, and how these ethical boundaries has been determined in IRB?
Okay, so there are the ethical determinations in the IRB. They're generally the rules, ethical rules generally aren't bound by country. It just happens that the federal government has regulations in the US, right? So if something is deemed unethical, right, by the IRB, it's probably unethical everywhere, right? So collecting someone's personal identifying information and keeping in a data set and selling the data set after you're done is probably unethical, right? No matter what country you're in. If you're experimenting on individuals, right? Let's say it's a pharmaceutical company, and you don't list and tell them all the risks associated with the drug, it's unethical in every country, right? Just so happens that the US has imposed ethical regulations. Maybe other country might not, right? But generally in IRB, it doesn't matter what country, and wouldn't assume that because you're in a country with no regulations that it's your ethics change, right? That makes sense.
Yeah, thank you.
You're welcome.
Thank you so much, Vito, for coming. Do you have anything extra to add in? I know that you're going to be sending a few articles at the end, and then we'll share that out.
Yeah. Okay. So one thing I want to be very cautious about when you're doing statistical tests is that you follow the rules that are set up for a statistical test. And the reason that the rules are there is because the math that underlines the program, the models, will not work unless these assumptions are followed. Okay. So these are not things that you can bend, right? It's almost like an honor system that you're following the rules. Okay. So be very careful when you're doing regression or ANOVA that you're referencing an article or you're referencing a paper and you're using all the steps that they showed you, because the steps are there for a reason. Okay. So that's my only concern. And also that I don't think anyone has any issues, ethical issues, but when you're writing a proposal, I would include as many details as you can, including the questions you will be asking and why you're asking the questions. Okay, because that'll prevent it from being deferred. Right. So if you have a lot of details in it and we say, well, this question is not good, this question is not good, we could tell you to throw out the question and then do the survey. right? But if you don't have enough details, you might have to rewrite the proposal, and that takes more time for you. Is that good? Any other questions?
All right, just a reminder, you guys are all working on your proposals. So make sure to really hone in on what questions you're going to ask, what survey questions, what you're going to use. Like, are you going to use Google Forms? Are you going to use Qualtrics that you may have access to, and so on. So it's really up to you on where you want to take this. And make sure to be really specific on the questions you're asking. Make sure those are the exact questions that you're going to be asking as put on the proposal from this. So thank you so much, Vito. Unless you have anything else to add, thank you so much for coming. And
Thank you guys for having me.
hopefully see you soon.
Thank you guys. Enjoy your research.
Thank you. All right, so everyone stay behind. So we have until 1:30 today. So today what we're going to be doing is really take a close look at your grades. And what you guys are going to be doing is just be heavily, well, you'll also have your, okay, so let me restart. You guys are going to have your